As usual, it takes a minute to set up everything. I hope you can hear and see me. We will take a second to let everybody in, and we are going to start soon. Meanwhile, I will start sharing my screen. It should be available right now. Please send a message to the chat box if you can hear me well and if you can see my screen. And if you will have any questions during this presentation today, please don't hesitate to type in those questions into the message box, into the chat box, and we will be able to answer those questions in the end. Okay, awesome. I got some messages from people who are still trying to join, so we will wait 30 seconds more, but I see at least 5 people mentioned that everything is fine with the sound. All right. Good. I think we are ready to proceed and ready to go with our session today. So let's start with introductions. My name is Oleg Ishchuk. I am in charge of operations at SDC Verifier. And today we are going to speak about structural verification according to rules and regulations for offshore structures. I am going to focus specifically on software interfaces, what to do and how to proceed to perform checks according to different industry rules. So in today's agenda, we will start with a very brief introduction of the company. Then I will show you the workflow. We will speak about geometry preparation, meshing, loads and combinations according to rules and regulations. We'll speak about structural members and its detection. We'll run through some checks. We will see how to present the results and come up with some conclusions in the end. Once again, if there are any questions, feel free to type them into the chat box and I will answer them in the end of this presentation. So, short introduction of SDC Verifier as a company. We are a Dutch company founded in 1998 by Wouter van den Bos, who is teaching in the Technical University of Delft, and he was doing engineering consultancy in terms of verification according to rules and regulations for a long time, and come up with idea that a lot of boring and repetitive tasks can be automated. So now we are 33 people in 3 offices around the world. We have hundreds of software companies, hundreds of companies using our software, thousands of happy users. But besides software, we also do consultancy. So we have hundreds of successfully completed consultancy projects. And all this is focused around SDC, which stands for structural design checks. So in the workflow of an engineer, you have a lot of problems to solve to comply with requirements of rules and regulations, but also to prepare the CAD data for your model, to run the simulations, to prepare documentation, to do so many iterations and so many efforts to finalize your design. Today we are going to focus around structural verification according to standards, and within the software, within SDC Verifier, it is possible to run global analysis and detailed checks for multiple different industry rules and for multiple different regulations. General steel codes like AISC, Eurocode, Australian standards, certification societies like American Bureau of Shipping, Bureau Veritas, DNV, and so on, specific industry rules like ISO, API, NORSOC, other rules for different failure modes. These standards are coming with lots of documentation. Basically, the standard is a piece of documentation which defines a method, a calculation procedure, which helps you engineers to be safe and to make sure that your design is okay. Because simulation itself is not enough to make sure that design is okay. You have to comply with the requirements to stay on the safe side and to be ensured that your design is correct. So the standards should not be seen as a struggle or a problem or a complexity. It is your safety, it is your insurance that everything is correct within your design. And this webinar today, this presentation today, is going to be fully focused around the interface of SDC Verifier software that does all the necessary pre- and post-processing steps to perform design, to perform finite element analysis, to perform code checking, and to document the results of all of these endeavors within a convenient interface. Today, I'm going to focus on SDC Verifier in its standalone interface, so completely independent from any FEA tools. But SDC Verifier also works as an extension, as a plugin to NSYS, FEMAP, and SimCenter 3D. So if you are a user of any general FEA programs, it is possible to have SDC Verifier as a plugin to those programs. If you don't have any FEA yet, or you want to have to keep your licenses for general FEA software for detailed design, and you want to have a tool which does everything all in one, SDC Verifier in its standalone interface is capable of doing all of this within one interface. So our project usually starts with the model. We need to get the model somehow. We need to start with the geometry. Within the interface of SDC Verifier, it is possible either to import the geometry, so you can import the step files, you can import drawings, you can import any kind of CAD files to edit them, to prepare the geometry, to convert it as into your FEA design. But it is also possible to build the geometry from scratch. So to start with every point and line and surface, and to do preparation of the geometry in SDC Verifier from scratch by copying the drawings, very old drawings that you have, or to start with new design and sketching. Nevertheless, if you have imported your geometry, all the functionality for mid-surfacing, central lines, geometry preparation, splitting, merging, intersecting, it is all there in a convenient interface to operate with curves, with surfaces, solids, to modify, adjust, delete, and so on. So all the geometry preparation is either done in your preferable CAD tool and imported from there and then prepared to be meshed, or you can build the geometry from scratch. Then you have to do meshing, and you have to run the to build actually your model with finite elements. So all the interfaces to perform meshing with either 1D, 2D, 3D elements, to assign the attributes, to assign cross sections, to define mesh size, to ensure connectivity, to define contacts, connections, joints, releases, boundary conditions. It is all within the interface to prepare the FEA model. We are not focusing that much on geometry preparation and meshing today, but all the functionality is there, and all the functionality is done in a very convenient way. For example, we have, if you have to model with 1D elements, there is a cross-section library where it's easy to navigate, easy to pick the cross-section that you would need. You can use a filter to find a cross-section out of 7,000 shapes library, the one in the way you want it. You can create a list of your favorite cross-sections or of the cross-sections of a specific type. So any list that you want, you can add cross-sections to the library, you can import new ones, and you can immediately create shapes in your model and to create this 1D element. So 7,000 shapes are available to create with the standard cross-sections of 1D elements. If you have to work with 2D elements and if you have to process the plate model and plate geometry, we have a convenient interface called Meshing Toolbox, which helps you to operate your geometry and to assign all the necessary attributes, sizing, to introduce intersections, to split the mesh in the areas where you would need to assign a proper sizing to make sure that you have a nice fine mesh to get very precise and correct results for your simulation. So nevertheless, if it's 1D elements that you need for beam member checks and joints and connections, or it's more detailed design with shells and solid for weld checks, for yielding or beyond the yielding problems, it is all possible to run and operate and conveniently create within the interface of SDC Verifier. When we have our geometry prepared, our model meshed, we need to assign, to define the loading conditions. And of course, the classic loads like nodal force, pressure, temperature, displacement, and so on, distributed force on element, on line, or on whatever you can imagine, is there and it's easy to create. But offshore structures are withstanding harsh environments of different complex loadings, and it's nice to have tooling to be able to define specific loads. So you are most likely to have wind loads in defined in your simulation. You are, since we're speaking about offshore structures, you are certainly going to have wave loading in your design. So this loads of distributed pressure, of buoyancy, of tank ballast, of winds and waves are complex to apply manually. So we have convenient tooling to apply the sets of loads in a nice and convenient interface. For example, if we are speaking about wind loading, it is done through an interface like this, where you are defining your distributed pressure. So first you start with a title, use good names, please. Then you select the vertical direction in the model and the direction of the wind in global coordinates or custom by vector. And you can say, I want to apply the wind every 30 degrees from 0 to 180. Then you define the portion of model to be subjected to this wind and define, would you like to have pressure or velocity over height? You can load the wind profile from the library, or you can create it and store it in the library, or you can create basically any format of the wind in terms of pressure or velocity over height, where you use this convenient interface to add reference points and pressure or velocity. Then you store it to the library, and you and your colleagues are able to run this to apply these winds of the same profile for your other models. You press OK, and the wind is created. And if in this case we had every 30 degrees from 0 to 180, 6 wind loads of 0, 30, 60, 90, it's actually 7 wind loads are going to be created. You can adjust the profiles, you can adjust the definitions, and you can also create other loads like wave in the very same interface, where you would have to enter a bit more of parameters of the wave, like height, period, and the distributed pressure of that will be applied to your model. If you work with vessels, buoyancy load can be calculated either by predefined waterline or by mass and water density. So all this tooling to apply loads is conveniently introduced in SDC Verifier. Next is loading combinations, because loads itself, it's nice to have, but our structure works in harsh conditions and it has to be checked for multiple different scenarios. So here we have this design of kind of a mud mat, and I'm going to show everything on that design. And it has certain transportation conditions when it has to be just delivered on site on top of a barge. By the way, for that we would need compression-only supports, which we have a specific tool for that. It's not a part of this webinar, but if you're interested in compression-only support in simple global analysis, that is easy to do with SDC Verifier within the static interface, with no need to go into non-linearity. Please send me a message if you would like to see that more. But besides transportation condition, you have operational cases, you have installation and retrieval, you have all kind of environmental cases. So lots of different loads has to be defined with factors, safety factors, coefficients, and it is predefined by table and SDC Verifier by table from the standard. And SDC Verifier brings to the users a convenient interface to run this and to build this matrix based on superposition to create as many of these combinations as you would like to have. How is that actually done within SDC Verifier? We start with individual loads, where individual load is a single influence on your model, which can be created either from calculation load or from existing outputs. So you can create individual loads from outputs, or you can just combine your FEM loads with constraints, press OK, and your model has now 9 individual influences. You see gravity, accelerations, some forces, and winds. Then you can define predefined load cases by standard or create them manually. So you go to load sets and you have this matrix where you are able to select how many cases you would like to add, and then define the factors and include everything that you would like to define in your model. So while we have acceleration loads, you can define for your FEA analysis just only one unit load of, let's say, 1 meter per square second, and then introduce the factors for the combinations to define different Z states. So it could be 3 base cases, acceleration in X, Y, and Z direction, but at the same time, user is able to identify unlimited amount of loading combinations within this load sets. So that can also be applied if you don't know the magnitude of your load yet, or if you want to test what's going to happen if your load is multiplied with 1.76. Moreover, you can add logic cases, like for winds, you can add positive and negative cases, and to see the influence with in X direction, in minus X direction. If it's 1D elements, it's easy. So within this interface, you create the matrix of loading, and you can also copy it to Excel, store it for your future project, select everything, copy to Excel, and it's there. You can, in the same way, paste it from somewhere where you have it stored before. So after you do this, you press OK, and load sets are created. So we have 12 loading combinations that we will take into account in our model. And then we have load groups, which are envelope set of results. So you see minimum, maximum, and absolute values on specific selection. You can do load group of individual loads, you can do load group of load sets as here, or you can even do group of groups to define the worst possible scenario for ultimate limit state, for example. After we have defined our mesh, our geometry, our loads and its combinations, it's time to run the analysis. Within SDC Verifier, it is super easy. You click one button, analyze, if you have one solution. If you have multiple jobs to run, so you can do linear, you can do basic nonlinear, you can do normal modes, vibrations, buckling, etc. So that is regulated within the jobs. Here we have created only one, but you can have as many of them as you want. So you press one green button, play, and yeah, it's as simple as that. It runs the solution. In case if you use SDC for ANSYS, FEMAP, or SimCenter 3D, it will run the solvers of those tools. For our standalone interface, we have SimCenter Nostrum solver with multiple different solutions and all the necessary solutions for code checking and for basic analysis. So linear, static, normal modes, vibration, buckling, transient, heat transfer, basic nonlinear, etc. All 100 solvers are included for SimCenter Nostrum. So it comes in a bundle with Nostrum to run your analysis. But it's a classic FEA, and this is actually what differs SDC Verifier from other code checking tools or dedicated softwares that do checks on structural members immediately, where you have to model with structural members. We do code checking on FEA, and your finite element analysis model, it's let's say million of finite elements or hundreds of thousands of finite elements. But checks are not done on finite elements. Structural checks are done on structural members. So we need to identify those structural members out of your finite element analysis model in some way. So how to do that? Very easy. In SDC Verifier, it's one button click, literally one button click. I will show now, to identify all the joints, connections, beam members, plates, panels, stiffeners, welds, etc. All the structural members within one click. When you are in the interface of SDC Verifier, you can go to recognition portion in the tree or recognition tab on top, and you click button recognize all, and SDC Verifier runs the check, and it's for this size of the model, which is 50,000 elements, it's almost instant, and everything is recognized now. You can call these tools one by one and recognize only the ones you need. So here you can see that all the joints in our model are identified. You have full control over the list of those members. You can merge, split, delete, and so on. So software within one click recognize all, is identifying each and every structural member in your model, joints, beams, plates again, and so on, and gives you full control over those members. You can filter them to understand better. You can play with settings to adjust recognition if you think something is not correct. And weld detection, it's a very tedious process to do it by hand. With SDC Verifier, it's one click, and the forces and stresses welds are identified. Forces and stresses are rotated into the weld directions. We have all the connections defined. You can also see that it defines where is a chord, where is a brace, and when it's something unidentified or hard to identify, it will highlight it for you to show to you what is there and how is that possible. So what you would do next would be, what is possible to define and what is available is all the structural members in your model are identified. So now we know the dimensions of those members. We know the parameters of those members. We know the results, more importantly, on these members. So we are ready to use them for code checking. And that brings us to the next interface of SDC Verifier, where you, as you can see, you travel through this ribbon step by step. And we are now on a standard stage. So in the library of SDC Verifier, there is more than 45 different rules and regulations implemented. All the basic and main crucial codes for offshore industry are in the library of SDC. We have API RP2A, we have AISC 360, ISO 19902, we have ABS and DNV rules, Bureau Veritas rules, Eurocodes checks, and so on and so forth. everything that you might want and need is already there. If you use some specific checks or some specific cases, it is possible to add this, and it's possible to add this either by us, or you can add this yourself, because the interface of that is open. I'll show it slightly later. For now, I would like to show you how to create that standard. We're going to set up AISC beam member check very quickly. To do so, you go into standards in the ribbon and you select the standard that you would like to work with. Slightly cut. So we have AISC standard here, and every standard starts with this kind of a dialog window with items which we cannot necessarily automatically define. So you first select the method, ASD or LRFD, then you define the section build type. You can define the lateral torsional buckling factor, CB, either to calculate it based on formula from standard or define it manually by user. You can, since this standard is cross-referenced with API RP2A for tubular shapes, you can include this cross-reference. You can select a portion of model to be used. So by default, it's all the shapes that are supported, but you can select all entities. Obviously, it is done on beam elements, and then you press OK, and the check is created in your library. And in the very, very same way, it is possible to create any other kind of checks. So we have just created AISC 360. By the way, we have different versions of 89, 2010, 2016, 2022. So we are constantly keeping these standards up to date, and we are keeping the old ones because I know that AISC 89 is pretty common to use still, because lots of equipment was built according to that standard, and so on. It is possible to do API RP2A for both members and joints. It is possible to create ISO standards as well. You see that the dialog windows are differing slightly, but they are all designed to communicate with the user to call for certain factors or parameters which we cannot automatically identify, or where user has to, where the human being engineer has to make a decision. And all of these factors, they always have a description in our help pages. So you're not necessarily should remember the full 100 pages document and memorize all the coefficients. In SDC Verifier, there is always a reference to where it's taken from in the standard and how to define this factors. In the same way, it's not only to 1D elements related. So if you want to run DNV RPC203 fatigue, it is also there. You will have to identify the SN curve and the weld quality to run the fatigue checks. But on 2D or 3D elements, it's possible to run fatigue checks. Then we have piping. We have SME B31.8 to where, yeah, you can see that there is slightly more parameters to be identified for every pipe, but pipe stresses are checked within the same model. So imagine you have this MUDMAT with global analysis, with transportation cases, installation, retrieval. You check members, you check connections, you check welds, you check piping, everything within one interface. You don't have to jump through different interface. You don't have to jump through to other spreadsheets or tools or your colleagues for other checks. Everything is in one interface. And why it is important? Because if you have to do changes, if you use 3 different tools, then you will have to implement those changes in all 3 tools. It's nice to have one interface for everything. And lastly, it's also possible to do plate buckling, of course, ABS, DNV, Bureau Veritas, Eurocode plate buckling. We are detecting the plate dimensions. We know the stresses on plate, or we can calculate. You define the type of stresses you want to use, averaged or non-averaged, maximum on plate, etc. Method of calculating that stresses, and run the plate buckling for each and every plate on your model. So Buckling analysis from solver gives you a buckling factor for one panel. You stiffen that panel, it's okay now. You rerun the buckling analysis with solver and you get the buckling factor for the next panel. So that's an endless loop. Code check gives you buckling strengths for each and every plate and panel in your model. So that's why it's much more convenient to use, because you know that your complete model is correct within one iteration. Well, or maybe incorrect, but then you know all the panels that has to be stiffened. Beauty of this approach is that everything is open. So we use results of general FEA analysis, parameters of your structural members that we have detected, and definitions of factors and options that you have set through those dialog windows as variables to create formulas. So this is your code check, and you can see it. You can see the formulas. You can see the references to those formulas. You can see your intermediate results and play around with this. So moreover, it's not only possible to see the formulas, it is possible to modify the formulas or create your own. So you can say that I don't believe in AISC, I want an extra factor of safety. You go to the check, convert it into custom. Obviously, it won't be called AISC anymore, but you can call it my personal code check based on AISC rules with extra safety. Introduce your factor, so modify the formula, introduce your factor, and use that for code checking. So it's unlimited. If you have some scripts that you use, or you do spreadsheets, or you do hand calculations, you can automate it all, and you can automate it all for your complete model under unlimited amount of loading combinations for all structural members in your model. So it's a one-click solution. Well, not one-click solution, but one click for every iteration to have everything within one interface once again. And then it brings us to, we would like to see the results of those checks, right? So we have created multiple standards for our model. We have member check of AISC, we have API join checks, we have ISO check, we have D&V fatigue, and we even have piping, even though I excluded piping from this ModMat model, but it is in there in a convenient interface. So what you would do next to see the results, you are able to select the check that you would like to have for those results, open it, and see the list of formulas. So as I mentioned, see the list of checks and all of the formulas. Then you can select any of those checks. Sorry, this video is a bit cut. And click on edit the formulas. So formulas are open. You can see everything. You can modify if necessary. If you want to preview the results, you go to the check, create a table or plot. In this case, we have generated a table based on load groups, and we have defined the damage, the utilization factor for different modes. I decided to add more results for all the individual loads and load sets. And here is the full table, which highlights for you that load set number 2 is causing problem for our model for bending and combined axial and bending. So we would like to know where that is. You can see that by element ID and load ID, but you can also see a colored plot. So you're calling for absolute utilization factor plot, and here it is for individual loads, and you can still see that with individual influences, it is all safe. It is all in the range below 1, in around 0.8. But if you do a plot on load group 2, where loads are combined, you will see that this 1.38 factor, utilization factor, appears in a specific area that has to be updated. And then what you can do is either use SDC Verifier optimization, or choose the different cross-section from library manually to update your design, or maybe modify your load. So you go to combinations and see that your load set 2, you made a typo and mistake with the factor, so you have to adjust it. You make the decision what to present, how to analyze, and how to adjust your design later on. And lastly, we want to present our results. So to do this, we have a tool called Report Designer, which helps to build a template-based document explaining the complete structure of your report. So you can define the structure, drag and drop items here, turn them on and off, and include description of your model, description of your materials, properties, loads, cross sections, boundary conditions, general FEA results. So in the same way as we just previewed utilization factors and with plots and table, you can take a look on stresses, displacements, reaction forces, include all of those results in a convenient report of your style. So you define the layout, you define your, if you say, I don't like this purple color and I want my own logo here, you define your template. It's quick and easy to identify this, to define this layout, and continue generating reports in your style, including general FEA result, code check result, parts of custom documents, and so on. And here you would probably ask me, Oleg, why do I have to make it in this interface if I have Microsoft Word and I can put everything there? The benefit of this comes with a template-based structure where you can firstly generate 300 plots for every loading conditions in let's say 5 clicks, so in a very quick way. But secondly, the benefit of this report designer comes when you have to update the results. Imagine you have prepared the report with Microsoft Word, and next day you submitted it to a customer or manager, and next day he asks you to introduce a small change. So you have to reanalyze everything and regenerate report once again. It is ridiculously time consuming, and it's, I don't know how about you, but I don't like to do the same thing repeated again the day after. So structure is saved, your project is saved, and all you have to do is your creative job. Modify the design, improve it, make sure that it passes the bending check of that, or fatigue, or whatever is the problem in this case, and regenerate report automatically. So the template is stored. And therefore, you generate a nice and full report with explaining everything. Here you only see the model setup, preparation, but also results, all of the parameters of that, and everything within one document, then exported to Word or PDF. So to sum up this workflow and this idea, what is SDC Verifier? It is a software that works independently or as a plugin to popular FEA programs. We offer simulation, FEA analysis, code checking, design optimization, and reporting within one tool. So it's either SDC Verifier standalone or plug into your FEA tool. Complete calculation procedure is stored and it's template-based, so you can quickly introduce modifications. You can use the same template for different design variation. You can use the same template for different setups of checks, or for different setups of your design, for different configurations within the same style. The workflow is scalable. You can start with simple, with 1D elements, and then improve to detailed design, to more complex code checks, and even if necessary to go beyond code checking, you can do all kinds of analysis, nonlinear analysis, different parameters. So I don't see limitations. What we are offering is a tool to enhance your engineering knowledge and to enhance your creativity, to enable checks according to multiple rules and regulations. And this is, of course, all nice, but the goal is, what is the goal of all of these endeavors is, of course, to save time and to make more effective designs, more profitable designs, and in a shorter amount of time. So SDC Verifier is a big time saver. This is a report. This is like a infographics of one of our customers submitting how much time he's now saving with using SDC Verifier. on hand calculation, on working with standards, on documentation compared to what it took him before. And it saves a lot of time on different tasks. In general, saving up to 50% of the time on modeling, analysis, and generating a report. And multiple companies around the world are benefiting with SDC Verifier solution already. A lot of them are in the offshore domain, but not necessarily its equipment manufacturers, operators, certification societies themselves, defense industry companies, general engineering consultants. All of them are benefiting with this workflow now, and you can do that as well. Also, a nice thing about SDC Verifier that you can get only what you need. So if you only do 1D elements and you don't need shells and solids, you can get a license for jacket structures for 1D elements only, be able to do member checks, joint checks, optimization, reporting within 1D elements only. So it is possible to get what you need for a very reasonable price. And don't hesitate to ask for quotations or to ask for what is the level that you would need. Reach out to our team and we will be able to help you. So with this, I would like to conclude that SDC Verifier is all-in-one software that enables structural design, FEA analysis, and standards verification. If you would have any questions after this session, please don't hesitate to connect with me on LinkedIn, reach out to me by an email, oleg@sdcverifier.com. You have, well, it's easy to find us. If you really want to ask something, it's not very hard to find SDC Verifier online or offline. We're happy to meet. We're traveling a lot for events and trainings, so let us know how you would like to if you would like to meet, how you would like to do that. At this point, I would like to conclude this screen sharing, and I will put on a screen an offer to you so you are able to download SDC Verifier and ask for a free trial. So on your screens now, you should be able to see a button to download and request a trial. Don't hesitate to do that. And if you're having any questions, I'm going to check the chat box now. I don't see anything either in chat or Q&A. We still have time for questions. So if there are any questions, don't hesitate and type them into the chat box. Also, my colleague Bogdan, if you would see any chat questions or Q&A box, please forward that to me so I'll be able to answer that.